Okay, so hey guys, today is our day 8 of doing Leetcode daily until I get a job. So today our topic is the sliding window, and these 4 questions we'll be trying to attempt today. The first 4 questions, okay, and rest of two we'll see tomorrow. Okay, so these are the first 4 questions. Let's start with the first one, which is best time to buy or sell a stock. We are given with array prices where prices I is the price of a given stock on the ith day. You want to maximize your profit by choosing a single day to buy one stock and choosing a different day in future to sell that stock. Return the maximum profit you want to achieve. You can achieve from this transaction. If you can't achieve, return a zero. So we are given a array where every element signifies the price of a stock on that day. Now we need to maximize our profit, means we have to buy that stock at one day and sell it on any of the future days, and if we cannot make a profit we have to just return zero. Okay, now what we can do is here is that at any day we will consider this as the initial buying price 7. If on the next day the price goes down, then we will make this as the buying price now, and if at the next day the prices goes up, then we will have a temporary variable where we will store this profit, and we will go to the next day. Then if still we are and the prices is higher than the buying price, we will again compare the difference. The difference on the previous day was 4, and now with 3 the difference is 2. So we are still not more profit, because if we sell that stock at this day, we will have a profit of 4 units. So we have to find that day where we can have the profit of more than 4 units. Only then we will update the current or the maximum profit. Okay, so this is the way we can do it. So yeah, we can start with the approach. We will just declare one answer. We will return it at 0, and current, that will be int min, and we will consider this variable as the buying price, and we will declare it as assign it the price 0. That's the price on the first day. Okay, now for int I 1 to I less than prices dot size I plus plus, what we can do here is that if buy price is greater than the current day's price, we will update the buy prices what is the price today. Okay, and after that once we did that, after that what we can do is we can compare the current as max of current and prices I minus of buy price, right? Buy price, and after that we'll do this answer of current. Yeah, that's how we do it, and we'll just return the answer. Cool. Yeah, this is correct. Let's go to the next question. This is the longest substring without repeating characters. So we are given us with a string, and we have to find the longest substring where the characters are not repeating. Every character is unique and distinct. Okay. So what we can do here is that let's firstly have a map was a character and integer. Okay, and in this map, if n is 0, I'm sorry, if s is empty, then we will just return 0. Now the answer to be, because we have to maximize this length, so we'll take the answer as int min. And after declaring this map, we will start iterating through this string as dot size I plus plus. Now in this loop, what we will do is that firstly we will simply just mp of s, um, we have to I plus plus, okay. Okay, this is when we do not have the character, this character si in the current substring. And let's say one more thing, and start is 0. So basically what this variable is for, that, see, let's draw the things here. Let's just take that this is the string, okay. Okay, this is the string we have. Now in this string, what will happen is start is here and I is here, okay, both are here. Now we will start iterating this string. First, this element, is this already in the map? This is the map, okay. No, it is not. Then we will just push it in the map and its frequency will be 1. Okay, now we go to the next element. I will be moved here, I will be removed from here, and I will be here now on this, on the second position, first index. Is this element in the map? No, it's not. We will push it to the map and its frequency is 1 now. Now I will be here. Remember, start is still there. Okay, I will be here. Is this element in the map? No, it's not. So we'll push it and its frequency will be 1 now. Now we'll come here, E. We will check it in the map. Is it in the map? Yes, it is in the map. And if it is in the map, then if our substring start from this S character, okay. Now we will check that if this element is in our substring, we will increment this S character and we will remove whatever is at A, S from the map. Okay, A is in the map, right? Because S character is at A, so we will remove this A, its frequency becomes 0. Okay, now we will check for the next element that yeah, we will check again that if there are any more A's in this substring, because S has now been here and we are checking only in this substring. No, there is no more A. Then okay, we will push again this A and it will be this. Start is at B now. Now we will come to B. When we come to B, we will check that is B there? Yeah, B is here. If B is here, we will start from the start index and we will see if there is a B. Yeah, it's a B. We will remove it from the map. Its frequency will be 0 now, and start will be at C now. And we will check now if there are any more B's. No, there are no more B's in this substring. So we will add this B to the map, and now our substring will be CAB. Again we will check C is here, so we will remove this C from here. So you can check that a window is sliding, right? A window, this window is sliding. This window will expand only when we get a new character which is not already in the string, and this window will be decremented if we get a character which is already there in the string. Okay, like B, we got C is already there in this string CAB. If we have this, we will remove this C and add this C to the substring, so it will be again sliding window with the 3 characters only. Okay, and again we are getting B, so now we will remove A, then we will remove B, and then we have a unique substring CB. Again we can add B, no B on. So what we will get is the maximum length. We have to keep track of the maximum length at every time. So yeah, this is the approach. Let's try to code it. So when we have to remove the element, when we are already having that in the map, right? So while start is less or equal to I, we need to do, because start index of the substring must always be equal to the end index. End index is the I, start is the start. Okay, I and if mp of si is greater than 0, Wait a second, guys. Okay, so if it is greater than 0, this character is already present in this map, then what we will do is we will just remove whatever is at the s start minus minus, and we will increment the start plus plus. Okay, and then we will input it into the map current element, and we will check the answer will be what? Max of answer and start index of substring I and index of substring start, sorry, and index of substring I, start index is start and plus 1. Okay, this will be the length. We will compare it every time when we will get the maximum. We can save it, and then we can just return answer. If we want to even return the substring also, if there is a question we have to return the maximum substring, then what we can do is we can s dot substring the start index and the length of that. So we have the start index and we have the length answer, so we can also find that substring. So this is how this question is done, and I think this is correct. Yeah, this is correct. So let's move on to the next question now. Okay, so longest repeating character replacement. So we are given with a string and we are given with an integer. What we have to do is you may choose any character of the string and change it to any other uppercase English character. You can perform this operation at most k times. Return the length of the longest substring containing the same letter you can get after performing the above operation. So in this substring, we have to flip any of the characters at max 2 times. Like we can flip B to any of the character, and like if we are given two chances, so if we flip B and B, both B's as A, then we will have the string as A, means longest repeating character. So A is repeating 4 times consecutively. Okay, this must be a substring. Okay, so this must be a substring, not subsequence. So the answer will be 4 here. Now here case 1, so we can only flip one character. Which character should we flip so that we can get the maximum longest substring containing the same letter? We can flip this B, then we will get the 4 length of this substring A. Okay, so now what we can do here is, okay, um, do we have to use the map here? Okay, we can, like, we can do it without the map, can we? But no, I guess map is needed. Let's try to solve this. Okay, let's say this is the substring. Okay, now in this substring we need to what do? We will start from here only, from the first element. Okay, we will have two pointers here, um, I and J. Okay, I and J are currently here. So now what we will do is we will start incrementing J, and I will be the starting index of this substring with the longest repeating, that the required substring. Okay, so now what we will do is we will have a map also. Whatever is at J, we will store it A, and we will its count 1. Okay, now what's the current maximum and what is the final maximum? Okay, current and our answer. Let's take two variables. Okay, current will be what? Current will be max of current and and MP of current element, that is the SG, right? Current will be this. And when will be the sliding window be shifting? Like, see, this is currently the sliding window. Okay, we're fine with it, right? We're fine with it. Answer will be what? Answer will be max of answer and J minus I plus 1. Current will serve a different purpose. Let's see what it will be. So current sliding window is this. Now we go to this element, J incremented, J's, and sliding window can be it because there is no, still there is no repeating character here. No, there is only repeating character here. Okay, and now A's count is 2. Now we encounter a P. Now in this substring, when J is here and AAB is the substring, at this time, how many characters are there? If we flip, it can become a same character substring. Only one character is there. If we flip this, we can have the same character substring. And what is the value of K? It is 1. So we have to compare these two values, that how many flippable elements are here. If we flip them, it will be the same character substring. And what is the value we have that we can only flip at max these times. So how do we find that thing, that how many characters are there? If we flip them, it will be the same character substring. So how many elements are there? How do we find that thing? So it can be, this is the length of the substring. Okay, currently this is the length of this substring, right? J is here, I is here, 2 minus 0 plus 1, 3 is the length. And second thing is, if we minus current from it, what is current here? Current is 1 here because we are at B and B has a frequency of 1. Okay, if it was A here again, let's just say it was A here and this side is K. If it is greater than K, the number of elements which we need to flip to make this substring same character substring, if that value is greater than K, then we cannot afford it. Okay, it must be at max equal to K. Then what we will do is we will increment I and slide the window from there to first element to the second element. Okay, only then we will do that if this condition is true. Now let's just check this condition on this element. Okay, when we are at A, 1A we have already get. Now if we are getting it again A, then J will be 1, I will be 0. 1 minus 0 plus 1, 2, minus current will be 2 because A has become 2 here. So it will be 2 minus 2, 0. Is 0 greater than 1? No, it's not. So this condition will not be true. Window will not be slided. And we will just go on with this one, and answer is maximum 2 up to here. Now when we get this B, now J is 2. J is 2, I is 0. J minus I, 2, plus 1, 3, minus current. At 1, what is current? Current is max of current and MP of SJ. Current up to now is maximum 2. And MP of SJ, yani MP of B is 1 right now. Because B has only come 1 up to in this substring. So current will be 2. So 2 minus 0 plus 1, 3 minus 2, 1. Is 1 greater than 1? No, it's not. So this condition is again false. What does this tell us? 1 greater than 1. That we have this as the maximum of what we can do. Okay. And we have this value that we can, if we flip these many characters, we will have the same character substring. Okay. This is our maximum limit. If one more different character comes here in this substring, we will have no choice but to slide the window. Okay. So but still we can do, because we have one chance, and if we flip this b, it will be a. We are good. So now again answer will be 2 minus 1, 2 minus 0 plus 1. Answer will be 3 up to now. Now next we again get a. Now a frequency is 0, 3. Current becomes 3. Current will be maximum of 2 or MP of a. A is 3 now. So current will be 3. So and J will be again 3. So 3 minus 3, 0 and 1. It is again 1 greater than 1. No, we do not, this condition do not satisfy. So we will increment the answer again. Answer will be 4 now. Now here we get a B. Now the things happens that this is the window for now. Okay, when we go here, when j is 4, I is 0, plus 1 minus current. What is current now? Current is max of 3 comma current frequency of b. B's frequency will become 2 here, but current is still b is 2 here, but current is still 3, because it will be maximum of 3 and 2, and current is 3. Okay, is it greater than 1? So it will be for 5 minus 3, 2 greater than 1. So it will this condition will satisfy. We will remove the element which is at the start of this substring, MP of Si. We will do a minus minus here, and we will do what? Increment the I to the next position. We will slide the window by one position. Okay, that's what we meant to do. And we can also see this logically, that if we include this B in this substring, there will be two characters which we need to flip to make it whole A, and there will be three A's to make it whole B. And we can do nothing from both of these options, because we can do maximum one flip. Okay, so that's why this condition holds true, and we have to slide the window. So means this condition is our this condition is a good condition for this question, and we can solve it with the help of this. Okay, so now let's go to the question and start doing it. So what we need to do is we can take a map here. So cat and int and map. We will take int I comma j, both as 0. Okay, and if s is empty, then we will just return 0 simply. We don't need to go anywhere. Okay, now in our answer is what? Int min, and our current answer is also int min. Now for the loop, while we will increment the j, right? While j is less than s dot size, what we will do is mp of sj plus plus, right? We will increment the sj's count in the map, and if and then current will be max of current and sj, mp of sj, actually mp of sj, right? Now we have the current and we have the element here, and now we will apply the condition. If j minus I plus 1 is the length of that substring, and minus the current, if it is greater than k, then what we will do is we will just remove the starting element of the substring from the map, starting character, and we will increment the start of the substring. Means we will slide the window, and we will obviously insert current element in the map, and we have inserted it. Obviously we inserted it, so we will slide the window one element to the right, and we will update the answer. Answer is max of answer comma j minus I plus 1, means the length of the current substring. Okay, and obviously j is incremented every time. and we can return the answer. Okay, apply this. Yeah, it's correct. Okay, and remove it. Okay, yeah, it's done. So let's go to the next question. This is the permutations question. We are given two strings s1 and s2, and what is a permutation is a permutation of a rearrangement is the rearrangement of all the characters of a string. So we have to check if s2 contains a permutation of s1. So s2 is a string and s1 is a string. Okay, we have to check if s2 contains any substring which has same characters as s1, means a and b. Must there is there any substring in s2 which contain ab? Yeah, it is here, b and a. Now in the second example we have ab. It contains a and b both, but not as a substring, so it will return false and it will return true. So what we can do here is similarly what we did in the last question. Okay, nothing like different from there. We can take these two strings. Let's start try to build up a method now. Okay, we have these two substrings. In these two substrings what we can do is uh, yeah, so what we can do is we will store this inside a map, right? We will store it inside a map. We will take a map or a vector of 26. So yeah, in the last question we could also have took that, just a vector of 26 length to store the frequencies, because in the case of characters they are only 26, so we can take a fixed length so that space will be constant. Okay, instead of a unordered map. So we will take a container or dictionary, we can say anything we can take. So if we take that and we'll store these the frequency of a and b. Okay, we will take a map or anything and we will store that a and the b are the elements which we need to search, and both have one and one frequency, and they should be in a substring, means consecutive. Okay, a or b, b or a. So first condition is if this substring comes out to be bigger than this, like if there's this more length than this, then obviously we'll return false right there. Okay, and if this is not the case, then we'll move forward. We will store the occurrences of this substring inside a map, and after that we will start for the second substring. We will take another map for the s2. Okay, and we will take two elements I, similar to last question, and j at the initial point. Okay, and we will store the frequency of this here, e. E's frequency is 1. Okay, now what we will check, where we have to check is that if the substring we are considering in s2 is equal to the size of s1, at that moment we need to check that are these both are these both substrings have the same set of characters with same frequency. Like if I take ei, it will have the same length. Obviously if we are finding a permutation of s1 and s2, that permutation must be of same length as s1, right? We will take this length to 2, both have 2 length. Now we will check if they have the same frequency of characters. No, they are not, so we will move forward, then only we will slide the window, right? So right now we will get e. Okay, it has a frequency of 1. Now we'll check, is the current substring, means j minus I plus 1, is this equal to s1 dot size? Okay, yeah, is this equal to s1 dot size? No, it's not, so we will move forward. Another thing we will need to check is that is it so that the size is, if the size is less than s dot size, we will just increment s1 dot size. Obviously we will increment the j. Okay, if it is equal we will check if they are both if it is a permutation. Okay, And if both these conditions not hold true, okay, it's not equal and it's not greater, then it must be less, right? It's not equal and it's not less. Like this condition doesn't hold true when there are still more elements needs to be added. Okay, so if the this size exceeds the s1 dot size, then we have to remove some elements, right, from the substring we are considering here. If it reaches d and we have a start point at e, then this is a 3 length substring, right? This can't contain a permutation of this can't be a permutation of s1, right? So we need to remove some element from this, right, to make this length equal to this so that we can compare them. At that moment, what we will do, we will increment the I and we will remove E from the map. We will now have this. Okay, now we have the same length. We will compare. No, it's not comparable. Now we will include B in the substring. Again, the length exceeds the S1's length, so we will remove I from here. We have DB now. Okay, and we will also increment J. Okay, we have DBA. Is its length comparable to S1? No, it's more than S1. So we will remove D and we have BA. Now we'll compare BA and S1. Yeah, we got the substring and we'll return the true, right? So this will be the method. I will write the code, then you will like see how this actually works. It's pretty easy, like it's not a difficult question, it's a tricky question obviously, but not that much difficult. So what we can do is, if first condition is if s1 dot size is greater than s2 dot size, obviously we don't want that and we will just return false. Okay, we'll return false. Now we will take a frequency vector for s1, okay, for string s1, and it will be of length 26, and initially everyone have a 0 frequency. Okay, now int I and sorry, before that we will store to need the frequencies of s1 string in frs1 vector. So for char s of s1, what we need to do is frs1 s minus of a plus plus. That's basically the sky. It will return the sky code for it. S is the sky code, minus a will return a integer value. This will return an integer value. Okay, within this 26 range obviously. So we have stored the frequency. Now we'll take another frequency vector here, right, for s2, and we will take two values. So while j is less than s2 dot size, what we need to do is, firstly what we will do is, frequency of s2 will store what, s2 of j, s2 of j minus a plus plus. We'll store the frequency of that element, that character. Now if the length is equal to s1 dot size, then we can compare these two substrings, right? Then we will just return what, a helper function which will compare these two substrings, that is s1 and sorry, we can just compare these two. If they both are identical, if they both have the same set of characters with the same frequency, then it will return true, otherwise it will return false. And if that length is less than s dot size, we need to add more character to the substring, then we will just increment the j. Else we have more characters and we need to remove the character from that substring, means we need to make it short. We will slide the window to the right. And what does that meant, what does this means, what I meant by that is clear to you guys, I guess, right? That will be s2j, sorry, I, that's the starting point, minus a minus minus, and it will also do I plus plus, and obviously we need to do j plus plus. Okay, if it could be found there, it will be found out, otherwise we just have to return the false. So we have to write the helper function now. So boolean helper will take these two maps, these two vectors actually. So it will take this and this. Okay, yeah, it will take two vectors and it will compare. And how it will compare is that we'll run a for loop that will be of 26 fixed length, so don't worry about the complexity here. It's just the fixed length and I plus plus. So if fr s1 I is not equal to fr s2 I, we will return false, right? Else we will return true. I guess this will do the thing for us. What do you think? fr s1, fr s2, redefinition of parameter s1. What does that mean? Redefinition of s1. Should we do it private or something? Wait, 24. Where's the 24th line? Okay, oh, line 3. Line 3. So, okay, it should be S2. Okay, they are both the same. Yeah. Okay, it's giving an error to us. That is this. If it is equal to s1 dot size, if it is less than s1 dot size, we will do j plus plus. That's clear. Okay. If j minus I plus 1, the length is equal to s1, then we will check it out. And at the beginning, we just are entering this s2 of j plus plus I plus plus j plus plus, and s2 minus a, right? We are showing the frequency of s1. This is the returning function. We will compare for the 26 values, and if any of them is unequal, we will return false, as return 2. What could be the error here? Char C, char S of S1, FRS1, S minus A plus plus. Yeah, that's true, perfect. Then we will declare this. Okay, then we'll return this. We'll do two variable I and j. We will run the while loop while j is less than s2 dot size, correct? Frequency of s2 of j, frequency of s2, and s2 of j minus a plus plus, correct? If j minus I plus 1 is equal to s1 dot size, we will return this helper functions. And if j minus I is less than s1 dot size, then we need to add more characters to it. Else frequency of s2 minus s2i, s2i minus a, minus minus, right? And I plus plus j plus plus. So what is wrong here? What's wrong here? What's wrong here? What's wrong here? If it's equal to size, then we'll compare those. Otherwise r plus plus, otherwise this. The length of is always known, which is Mhm. But we can, okay, in C++, one more thing we have. Do we need to do this thing? Because we can directly compare the vectors, right? We can compare the vectors in C++. If we can remove this and return FRS1 is equal to FRS2, will it do the thing? I think it should do. There's no way it should not, but still it's not. Okay, S1. Okay, I got it. Oh, okay. I got the answer. Like when it is comparing AB to EI, if it's not comparable, like they are not equal, it will just return false from right there. It will not go forward or go after that. So that's why it's doing this. So we need to do like we will not return anything here. We will just see if they are equal, then return true, and if not, return false will be obviously done at the end. Okay, so this is the mistake we were doing. Got it. I'll submit it now. Yeah, okay. Yeah, so there was just a small mistake which was happening, that we were returning it right there, like we are returning the boolean value right here only. Whenever we get the size of the substring equal to s1 first time, if they are equal, it will return true, else it will return false right from there, which should not be happening. Okay, it might be happening that AB could be found at the end of the S2, right? So we have to check all the possibilities, and if it's not there, false will be obviously written at the end. So these are the 4 questions. Okay, so yeah, we got this, and we'll do the rest of the questions tomorrow, right? And how much time did we take? It took 42 minutes, so yeah, fine. Yeah, that's it for today. Bye.